So, dear students, look here. This is here. Yesterday we seen up to some chapters. Now, third example, gravitational force. How it is? Look here, gravitational force. In this gravitational force, actually definition, force exerted by Earth's gravity. Force exerted by Earth's gravity is called gravitational force. Which force exerted by Earth? That force is called gravitational force. Here, apples fall on ground. Look here that example picture. Apples fall on ground. Look here. Gravitational force example. Apples fall on ground. That is one example. And look here, muscular force. Here, yesterday we see muscular force, but now also once look here, the force that is caused by action of muscles. Look here, muscular force. The force that is caused. Force should cause by action of muscles. Action of muscles, shoulders, muscles, whatever. Action of muscles inside the body. Force should create with the action of muscles. Then that type of force is called muscular force. It is a contact force already. It is a contact force. But look here. Example, carrying the bag. When schoolboy carrying a bag, then shoulders muscles will work out. And here, animals make use of this force, I mean muscular force. Animals make use of muscular force to carry out physical tasks. To carry out physical tasks, whatever may sitting, standing, working. Bucket of water, lifting a bucket of water, it is also comes under muscular force. And my dear students, we see one question, simply one question. Here, give two examples of situations in which you push or pull. Here two situations given, push and pull, to change the state of motion. Pulling time, pushing time, pulling time. Give two examples to change the state of motion of objects. Look here. Example 1a. We push a bicycle to move it. Simple example. We push a bicycle to move forward. And next, we pull the table to change the position. We pull the table while sitting time. We pull the table backward or frontward to change the position. Look, few more questions I will write for you. Right, look here students. These are the questions which we are practicing now again. I am reading one by one. Very clearly, give two examples of situations in which applied force causes a change in the shape of object. Shape, you should remember. Shape of object. Two situations needed. When shape is changing, shape changing situations we need here. So look here. Give two examples of situations in which applied force causes a change in the shape of an object. A. When we press the foam. When we press the foam like a double roti like one structure it was. When we press the foam, its shape is changed. Foam shape will change. And next one, when we stretch the rubber band, when we stretch the rubber band, rubber band shape is changed. Rubber band for hairs purpose using when you are stretching. Not only that, rubber band hand purpose using. Anyone when you are stretching rubber band, its shape will change. Next question. A blacksmith hammers a hot piece of iron while making a tool. Yes. How does the force due to hammering affect the piece of iron? When blacksmith using hammer to making a tool of iron, then which kind of weather will be beside of him? Not only weather, what changes occur in that iron piece to make that convert that piece into tool? To make that piece into a tool. So look here, what changes will occur? The force due to hammering, causes the change in shape first. Of iron. And iron can be molded. In the shape of the required tool. Whatever made, that is ox, whatever other tools. Iron plows are there, na? And gaddapara, whatever. Next, look here. Fourth question. Name the forces acting on a plastic bucket. Just take a plastic bucket with full of water and name the forces. What forces are acting on that bucket? Look here, containing water held above ground level in your hand. Why the forces acting on the bucket do not bring a change in its stage? When you are lifting a bucket of water, then the bucket shape will not change. Why? Which forces acting on the bucket to keep bucket in remains stage? In remains shape. Whatever. Look here. Muscular force and gravitational force both are working on the plastic bucket. Forces act on the bucket. The force acting on the bucket do not bring a change. Why? Look here. In state of motion, we are moving but not bucket. Look here. In state of motion, because they are acting. Who is acting? Gravitational force and muscular force. Both are acting in opposite direction. Gravitational force pulling downside. Muscular force lifting upside. When muscular force is lifting upside, gravitational force is pulling downside, then both forces remains zero. Resultant force is zero. I mean net force of muscular force and gravitational force becomes zero. Look here. In state of motion, because directions, look here, opposite directions with equal magnitudes. So, the net force on the bucket remains zero. Remember it.